All right, so let's go ahead and talk about the next part of our lecture, which is something that I know that you guys have wanted to try for a while. So let's go ahead and make a new file, and so I'm actually going to have to pause here afterwards to help you install, to make sure everybody installs it properly, and especially if you're using PyCharm. So, how to Excel. Okay, so now this will be chapter 12 of our textbook, which is how to work with Excel files. So we've talked about how we've already learned how to work with CSV files, right? And for this one, it's going to require a bit of prep work on your part. So I need you to go to Canvas, and under announcements, I posted all the files from this book. Okay. So go to Canvas, right? And there should be a zip file that has Automate Online Materials, which is all the files from this book, because this way you'll have some Excel file. If you unzip it, you'll find like a lot of stuff, including, you know, Excel files in there that we'll be able to work with. So this will be pretty nice. Okay. Also, another warning is that basically the book and the online stuff don't necessarily match. Some of the stuff is actually deprecated in the book, but you'll see. You'll see when we get there. The first thing you need to do is to work with Excel spreadsheets. Excel files are binary files. So we talked about the difference between like text files and binary files. CSVs are text files. Excel files are binary files, which means that basically if I open up this example, if I open it with the text editor, it tells me it's binary or large and doesn't, you know. If I open with Vim, it says I can't unzip it on my system. It's kind of, you know, it's if I try opening it with any other app, it's just not going to really work out for me. Right? I can dump this in and see. Right? It comes out as just a bunch of gibberish because that's what it is, as far as I'm concerned. Right? It's not something I can read. I can read about the printer settings, though. It's just not meant for me to read. Okay? So Python can't read it natively, which is why we need a library to do it. Okay? So the first step is to basically get let's see. The first thing we need to do is actually be able to install our module. OpenPyXL, that's what we're going to use. So you can test if your system has it by, you know, going into Python and then typing, or Python 3 rather, and then typing import OpenPy. Let's see. It was, sorry, OpenPyXL. And it yells at me because I don't have it installed. So fortunately for us, there's an easy solution for that. Okay, exit out. If you installed Python, there should be something called pip on your system. Now, depending on whether you needed to use Python or Python 3 to get access to Python 3 on Windows, you should just have to type Python. If you're on Windows, type pip. If you're on something else, type pip3. Pip3 is a Python, basically it's a package manager. So we can type in pip3 install OpenPyXL. Oh, and it tells me that pip isn't installed on the system. So go. Right, so I'll download pip. Or I'll, you know, fail to type in my password. And it will download, and let's pretend I do that, and then I'm going to quit. I'm just going to quit out bash, and So here on Windows, I can do pip3, I can do pip install open PyXL. And it's going to tell me that I've already got it installed. Okay. So I'll be around to make sure you guys are doing that just fine. So you need to go to your command line. So do cmd pip install open PyXL. This will get you that module. Okay. So yep. Pip is not a well, hold on. Can you run Python here? Okay, so you didn't. Okay, so what you need to do is that you need to go and go to Python. Go to the Python installer. And you're going to download Python. Oh, Python 3.7. Hey, that just got released today. Looks like it. Now, go to Windows 64 executable installer. And then when you open it, check the box that says add it to your path files. Okay. So. Others. There you go. Include title and okay, so now since you're using PyCharm, you may need to always. Yeah, but also. Yeah, so what you want to do is for your projects, for the project you're working in, file, especially since you're going to be installing Pip. Settings. It says virtual, basically sets it up so you can keep your Python installed directories separate. But if you don't care about that, you can go to here. So, then you can configure the interpreter instead. Yeah. System interpreter. You may have to remove that. So, okay. Are you able to install OpenPyXL?
I've already got it.
Okay. So we'll go ahead and keep going with this. Yes. Did it crash?
No.
Okay, so it's successfully installed. It's fine. So you can run that command if you want to upgrade Pip. If you want to. Ow, ow, ow. Okay. So we've got that. So now let's see what we can do for it. So part of this will want it. So part of this you will want to be working somewhere where we've got. You want to either grab your the file and move it to your PyCharm library or wherever you happen to be working, or write a script inside the examples. Basically, you need to be able to read the file that we're working on. And I'm going to be using the example.xls file. So let's take a look at example.xls. And I'm going to assume you're exactly like me in the sense that you basically never work with Excel. And you need a basic vocabulary lesson because you don't know Excel and you're supposed to teach a lesson on how to work with Excel files. Right? I mean, wait, no, I'm totally an expert on this. Okay, and Excel is called, so Excel files basically are metaphor, have used them a workbook, worksheet metaphor. I mean, in other words, you have a workbook full of many worksheets of paper, and each of them is just a grid that magically expands or contracts as you need it. Okay, and what's cool about Excel is that it's its own. You could make the argument that Excel is the most popular programming language on earth because it is Turing complete. You can do stuff like, hey, I want to sum all these up, so I can go =sum, and I want to sum up basically A1, not A1, but sorry, column C1 through C7. So what's the syntax for that? I think colon. C7. There we go. And it produces the sum, 497, right? I don't work with cell much at all. Okay, so that's fine though, because I don't need to, because I have programming languages for that if I really, really need to. So you've got multiple cells, okay? So basically so you've got multiple sheets. Each sheet is composed of cells, okay? And that's basically the entirety of it. You've got basically multiple sheets, each with multiple cells. And then all we care about is, can we put stuff into cells? And can we extract stuff from cells? And can we manipulate cells around? That's all we're going to be doing. It's actually kind of, it's just a matter of just learning the lingo, so to speak. So, so let's go ahead and now, so the first thing we need to do, of course, if we're working with it, is that we have to import OpenPyXL, right? Got to be able to import it for your program. Test your program at this point and make sure that that command runs, because if it doesn't, then anything else you do is trivial. So the next thing we need to do is actually we actually have to open up a workbook, open up the workbook, right? So, so let's go ahead and work with reading an Excel document first. Okay, so we're going to go with their example one, which has this spreadsheet in there, which dates, and then a bunch of fruits and stuff, and then column C. So to open it, we use the load workbook command, and we'll use WB as our variable here. So for the workbook. So WB is equal to openpyxl.load workbook, and then you give it the file name, example.xlsx. Run it, make sure it works. Congratulations, it works. So for very big workbooks, by the way, this will take a while. Like for example, for the one that we'll be working with in later, if not today, then next week, which is the U.S. Census data, Census Pop data. That one takes a while to load. Right, it's running. It's just taking a while to load it into the format it needs. Right. Okay. Now that we have that, we need to get the worksheets. Now, your book has this thing of using get sheet names and then get sheet by name. Honestly, it's a lot easier. The syntax has been shortened a lot easier. So let's go ahead and see what sheets we have. Print WB.sheet names. Run it. Says I've got sheet 1, sheet 2, so sheet 1, sheet 2, and sheet 3. Okay? Which matches what we've got over here. Got 3 sheets there. Okay? Sheet 1's, so let's go ahead and sheet 2 is kind of empty and lonely looking, so let's go ahead and fix that. Let's go ahead and load up sheet 2. To do that, we can say the sheet is equal to WB, and then normally there used to be they have a deprecated function, which means we're still supporting it, but don't use it anymore because we might not support it, right? Get sheet by name to load the sheet. And you would just provide, say, I'd like sheet 2. We can print sheet to see what it is. So sheet 2 does not exist. What was the sheet names? Sheet 1, sheet 2, no space. Capital S, no space. Right? It says, notice it didn't crash here. It says, it's a warning, call to deprecated function. Use instead this. In fact, it's easier to load a workbook if you treat a workbook like a dictionary. And that's exactly what we're going to do here. We're going to treat it like a dictionary, where the key is the sheet name and the value is the sheet. Yes?
I'm sorry, it's installed in Excel, right?
Yeah.
Okay, I can talk there.
Go ahead. Not find key Y. Key Y. Oh, I'm glad it was easy. But boom!
Thank you very much.
I love easy fixes. And that is why pair programming is a thing. So, okay, so we got the sheet, and it says, hey, it is a worksheet. Great, that's cool. Now what's cool is that basically we can actually access these things like dictionaries, which is nice. So what I can do is that I can do like this is I can go sheet, and then to access like a dictionary, I can say, hey, A1, in cell A1, I'd like you to put hello, comma, world, right? So we run it, boom. Let's open up example.xl again. So let me go over here to our example, and you'll be extremely disappointed to see that basically that there's been no change whatsoever to our example. Okay. Now this is because that basically you haven't opened Excel, right? In order for changes to be populated in Excel, you actually have to physically save your workbook, right? You have to hit the Control S button. So to do that, to save your workbook, to save any changes you do workbook.save, and then you give it the file name you'd like to save it as. So I'm just going to save this as new.xlsx, right? Now I'm going to run it. Let's go ahead and check. I have a new file over here that's called new.xls. I open it up in Excel, and it says, hey, here's all the stuff in sheet 1, but in sheet 2, it has hello world. Okay, so that's nice. Okay, so you can write to a single cell. Big whoop. What's that? What do you care? Let's go ahead. Well, with the power of loops, I can kind of automate this, right? I can say, hey, for I in range 0 to 100, okay, for let's go with letter in A. For letter in A, B, C, D, E, F. Okay, so now I've got an nested for loop. So for each of the letters in here, for each of these, and we don't want to start from 0, right? We want to start from 1 because all the cells, right, in the top right corner start at A1. Okay. We can do sheet, and then we can create the cell by going the degree for this dimension for the cell by going letter plus str I. Remember str to convert that into a string to concatenate those two things. Okay. What we can do now is that we can set that equal to I don't know. Can we do something like say import sys? Sure, for system sys dot. Let's see, do we have is there a time thing? How do I get the current time? Get current time, Python. Oh, let's see. How do I get the current time according to this? Import datetime. Datetime now. Sure, this sounds great. Let's import datetime. So instead of sys, import datetime. Datetime dot datetime dot now. Run it, and then this will overwrite the file that I currently have. So I should probably close that, because otherwise they might be fighting each other. Okay, write that, and let's go ahead and see what happens if I open up our file now. So open this one. So let's go to sheet 2. Well, it's got a bunch of hashes. That doesn't necessarily seem great. Maybe I need to convert it into a string. If not, I'm just going to simply go ahead and otherwise I'm just going to continue on, because that's not necessarily something we need to know about. So boop boop boop. Open sheet 2. Hey, there you go. There is the time. There is the current time with a very exacting degree for that each cell got written to. Isn't that so? So I filled up a whole lot of spaces very quickly there. Okay. So that's so. Interestingly enough, I did writing, and our book starts with reading, but writing is very easy to show that basically how you access cells. To get values from our cells, it's not really that bad. So I'm going to stop saving our file and making changes to it. So I'm going to multi-string this out. Instead, I'm going to go back to working with sheet 1, because sheet 1 actually has data in it. Okay, so that's our sheet now. Sheet 1 actually has data in it. What data does it have? It has numbers, and it has these values, right? So we can write a loop to kind of go through all these things, right? So let's go ahead and just. So first off, you can just get a cell, like cell is equal to sheet B1, and remember, you got to put these things in the string. Print cell, print the type of the cell, print cell dot. So here I'm going to show you we've got a bunch of things that a cell can do, assuming it can type correctly. Print cell dot value. Print cell dot row, cell dot column, print cell dot coordinate. So as you can see here, you've got this cell here. If we print out the cell, it just simply says it tells us it's sheet 1's B1, right? That's what I grabbed. I grabbed sheet 1's B1. Its type is it's a cell. It's just the weird way that it's organized. What's in the value is what's inside it. Apples, which if we check our example file, B1 does indeed hold apples. Okay. If we, sorry, keep clicking on the wrong things. So the row is 1. It's in row 1. The columns are the letters, so that's B. And I print out the coordinate, it gives me B1. Right? So all those things are stored there. Okay, so, it's fairly straightforward to go through. We can go ahead and go through all the stuff in B just by saying, hey, by writing the for loop. For I in B, let's see, cell dot, not cell, but sheet dot, why does it not, okay, to do stuff. You were doing autocomplete stuff so well. Sheet dot, let's see, max. There was a, well, let's just go with 4 in range 1 to 9. Print. Let's go ahead and actually grab cell is equal to sheet B plus str I, and then print cell. Let's print I and cell dot value, and let's also add in cell dot coordinate. So here we're printing out B1. So now we're printing out basically the value for I, the coordinate that we got, and the values there. Notice that B8 wasn't actually occupied, so it just printed out none because there was nothing in there. That makes sense to everybody? Okay. So if we want to find out, like, now mind you, when you're opening a file like this, you might not be wanting to actually open it in Excel, right? And you can't be bothered to count how many rows and columns are in there. So instead we can go like cell, we can do sheet dot get max. Let's see what they said. Get highest row. Get highest row, which is another deprecated function. In fact, it's completely obsolete. We can't use it anymore. Nope. I think what I had to do last night was that it's actually max underscore row. And now if we do a max underscore max row plus 1, that will actually include that last row in there. So you can get the max row and the max column that way. Okay. Now, Excel is slightly tricky when you're trying to do a lot of columns because it doesn't do numbers, it does letters. So when you get to Z, it goes to AA, AD, AC, AD, which is really nice and easy to navigate, but can be slightly hard for you computer-wise. But there's probably a solution. Oh, speak of the devil, converting between column letters and numbers. Right? You can use cell.getColumnLetter. So, for instance, so here's an interesting thing. It's saying from the module OpenPy cell, just let me use these things without having to do cell dot OpenPy Excel cell.getColumnLetter. Right? It's saying, like, please make these methods available to me as though I had written them in my file. So I don't have to use a command, a special command to do them. And I bet you it's saying it can't find a reference to them. Let's go ahead and see. So the issue is that basically it looks like they've updated it since the book came out. Isn't that fun? So let's go ahead and look. Automate the boring stuff. Boom. Working with Excel spreadsheets. I think that's more up to date over here than my PDF. Converting between letters and numbers. Get column letter. Get column index from street. Nope. So get column letter. Open PyExcel. Error. It says you can't get it anymore. It has been put into openpyexcel.utils instead of py.cell. So they've moved where it was in the code. It's no longer in the cell code. It's in utils. Which makes sense. These are utility functions. So let's go ahead and let me go ahead and open a Python. Actually, yeah. Sorry, what was that?
Is that working?
Yeah, it doesn't give me errors anymore. So let's go ahead and let's go ahead and just comment these out by normal and comment out everything else we've done. Okay. So now let's go ahead and do, you can grab these out. So print get column letter. So for instance, column 55, if I put that in, it'll produce BC for me. So there's a way, so there's an easy way for me to convert that into letters, and then print column index from string. That's an index that I can use to say, hey, I want what the heck is FA, right? That's a string. What the heck is it? That's 157, right? So there's a function already built in here that allows you to convert from most from the columns appropriately. All right, but so here's another useful thing. You can slice things. You can use the slice notation to get stuff, right? Normally, like you would use just how you would use the how you would in when you're actually working with Excel. How if I opened up example again, right? I can grab a section like this, just like you can do that in Python in there graphically. We can do that over here. So I can say print sheet, and then I want to grab A1 to slice C3. Oh, why did I add brackets there? I don't need them. A1 through C3. So that's slice notation, right? And it tells me that I just grabbed A1, B1, C1, A1, B2, C2, A3, B3, and C3. Okay? So now I can do, so I could do like for row in sheet, for item in row, or actually cell in row, cell dot value. You want to print cell dot value. And there we go. I got the date, apple 73, date, cherries 85, date, pears 14, which matches this selection right over here. What about if I just did this? Just C1 through C5, C3. It understands that I just want to do that vertical selection there. So that's very nice. So it grabs each row and returns each row to you. So you can do slices like that, and that's a very, very common operation. What if I did C1 through C7? And by the way, notice that the slice notation in this case is inclusive, right? 1, 2, because we're working from the starting index of 1. So our starting, and that means that for our math to be correct, we need to be inclusive on both sides. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So these first two numbers are from here. Okay. That's pretty nice. Again, run it. So can we use other parts of slice notation, like going by 2s? Let's go ahead and find out. Nope. Adding in that 2 does not seem to care. Can we do but can we do this? C7 to C1. Does it care? It gives me out of range. What if I went negative by -1? Nope, not that, not like that. But once I got those, I can of course go through the list in reverse. Right? I can go through the resulting thing in reverse, which means that if I do this, C1, C7, there we go. And now I made a copy of that and went through it in reverse. Okay. So, they're not giving you a list, by the way. Instead, what they're doing is giving you a tuple, which is very, very similar to a list, only they're easier to add together. We didn't really go over them, and it's not really important that we do go over them. All right. So this is so over here is a pretty fun thing that I wanted to do, but I think we're lacking in time to do it, was that we do have this nice giant data set that the book provided us, which is the census population data. It is a large Excel. It is fairly large. As you can see, I'm at the bottom. I'm near the bottom of it. There's 72,000 rows in it, or almost 73,000. That goes by every single United States, and then basically it gives you the census count for each census tract. So the thing here where Excel will really shine for you, okay, is the fact that basically, each county, a state is divided into counties, okay? In the United States, the government divides the entire country into states, and each state is itself divided into counties, okay? So, each county, though, is further subdivided for the census, which is a count of the U.S. population that occurs every decade, which actually did require there was actually a dangerous point where basically they were worried about the U.S. population getting so big that they weren't able to count it by hand anymore, and then fortunately counting machines were actually invented just in time for that to not be a problem. So, but anyway, a county is divided into these populations over here, and suppose I wanted to actually get the sum of all the counties, right? So over here I could do equal sum of, just select all of those from Autauga. Right, and I can select them, right? And it's not exactly a error-proof process because human fingers are a bit slippery, right, and inexact, right? I'm going through these guys, but it's super easy for me to accidentally select one more and accidentally grab the extra 3,000 people from Baldwin if I want to figure out how many people are in Augusta, right? Oh, sorry, not Augusta, but Autauga, Alabama. Okay? So this is where having a computer is kind of useful. So the project they describe and what I'm going to go over on Monday is that we're going to open this up and we're going to work through this project together. Where basically we're going to read through the program is going to read the data from the Excel spreadsheet. It counts the census tract in each county, counts the total population of each county, gives me basically the population total in each county, and then prints the results. Right? So it gives me it will give us the county by county results. Right? And this you can imagine this might be something that, as just somebody having to do data, getting thrown this from by their boss and saying, hey, we need you to do this, or we need to do something similar to this that involves you at a repetitive task where everything's organized already for you. Okay. Now, there is a slight issue here, which is that basically that there is one slight complication than basically just making a single dictionary and holding it in, and that's that each state, while each state has no single state has two counties named the same thing. Multiple states have counties that have the same name. So in Alabama, they have a DeKalb County, and in Georgia, they have a DeKalb County, which I know because I lived right next to it, right? So it's actually quite a big county in Georgia. you know, and in Illinois, they also have a DeKalb County, which I know because I think I probably drove through it. Right? It's like how a single town probably won't have two main streets, but a lot of towns do have a main street in it, right? So you can't just go, okay, if county is over here, right? Just add them up. We actually have to make a dictionary of dictionaries. Yes.
Could you also just make a dictionary that's adding state and county?
That would also work. So that's another solution. We could do a dictionary of dictionaries, but I like your solution more because it's simpler. Where basically we could have Illinois, we could do IL, comma, McDonough, right? Or IL, DeKalb, and GA, DeKalb. That's a good solution. It just depends on how you want it organized. But basically, you can imagine that it's a repetitive task that's easy for you to get wrong, right? If we left it up to a human. But with Python, we can not only make it error-proof, we can also make it get done a lot quicker. Okay, which is kind of what the purpose of this, what my purpose of was, to teach you enough to also go into to continue programming if you want, but also to show you stuff that basically, if you're condemned to be an office drone for some reason, then at least you can maybe automate your job so that you've got a lot more time to browse Reddit or something.